Today we will be solving real-world systems of equations using elimination like yesterday's lesson. Your first step is to read the problem. Second, identify the two variables. Third, write a system of equations that can be used to solve the system using elimination. 4, solve for one variable. 5, substitute the solution found in step 3 into each equation to find the solution for the entire system. Please excuse the bell. So let's take a look at this first one together. This one is set up for us so we have a first equation and second equation. The sum of two numbers is 36. Their difference is 24. Find the numbers. So again, in this first equation, in the first sentence, it tells us what our first equation is, the sum of two numbers. Since we're using the elimination process, we know we need two variables, okay? So we are going to say x is one of the numbers and y is one of the numbers. So we have the sum of two numbers, x and y, x plus y is equal to 36. And then similarly in the second equation, we have their difference is 24. So again, x minus y equals 24. And just like yesterday, we're going to use the process of elimination. And in this case, it's really easy because there is already a pair of opposite coefficients. So we're going to go ahead and cancel out the y's and add everything else. X plus x is 2x. 36 and 24 is 60. Divide by 2, divide by 2, x equals 30. Now we take that 30, plug it back in to find y. 30 plus y equals 36. Subtract the 30, subtract the 30, and y equals 6. And there we're done. Okay? We know that the sum of 30 plus 6 is 36. We know that the difference of 30 and 6 is 24, so we are correct. Let's take a look at the next one. This time we're dealing with coins, and we've done a lot of coin problems this year. So we can solve coin problems using systems instead of doing one long equation and only using one variable. We can use two variables. So Emily has 18 coins in her pocket, nickels and dimes. So let's let N be nickels, dimes be D. We know there's a total of 18 in them. So our first equation is just going to deal with the number of coins we have. So we have a certain number of nickels plus a certain number of dimes for a total of 18 coins. Then our second equation is going to deal with the value of those coins. So now we know that nickels are worth 5 cents each. We know dimes are worth 10 cents each. And we know that Emily has a total of $1.40. Now this one's not as easy as the last because we don't already have a pair of opposites. So we have to go ahead and multiply in order to either eliminate the n's or the d's. So since both the n and the d are 1s, I could just choose either the coefficient in front of the n in the second equation or the coefficient in front of the d in the second equation to multiply the top equation by. In order to get opposites, I need to multiply by a negative. I prefer multiplying by 10 than 5, so I'm going to take the 10 and multiply the top equation by negative 10 cents. Then we distribute the 10 cents across the entire equation to create an equivalent one. And we wind up with negative 10 cents N minus 10 cents D equals negative 180. We bring the second equation over, and then we use the same process. Adding vertically, we get negative 5 cents N. The D's cancel out, equals negative 40 cents. Divide by 5 cents. Divide by 5 cents, and we get n equals 5 goes into 48 times 8. So now we figured out that we have 8 nickels, or Emily has 8 nickels. We're going to take the 8, plug it in, and find the number of dimes. We have 8 plus D equals 18. Subtract the 8, and D equals 10. And finally, because it's a word problem, we're going to write a sentence. Emily has 8 nickels and 10 dimes. Done. All right, number 3 is very similar to this. Take a second, read it to yourself, see if you can come up with the two equations. Again, start with one that just tells us the number of coins that Jeffrey has, and one that gives us the value of those coins. Okay, so in this case, she has 24 coins in all in quarters and dimes. So we're going to start with G plus Q equals 24. Then we add the value, 10 cents times D plus 25 cents times Q equals $3.75. Now, just like we did in the last one, we're going to multiply the top equation by one of the values of the coins and, of course, make it negative. Okay, so I'm going to take negative 10 cents and distribute across this equation to create an equivalent equation. We get negative 10 cents D plus negative 10 cents Q equals negative $2.40. Bring our second equation over, 10 cents D plus 25 cents Q equals $3.75. And then solve by eliminating. Our D's get eliminated because we have opposites there. 25 cents minus 10 cents is 15 cents. 375 minus 240 is 1. 5 minus 0 is 5. 135. Divide by 15. Divide by 15. And we get Q equals 9. Then we take the 9, plug it back into our original equation. We have D plus 9 equals 24. Subtract the 9, and D equals 15. So we can say Jeffrey has 9 quarters and 15 dimes. So those three were actually some of the harder ones. The next couple are a lot more obvious in my opinion as to how you're going to set it up. So let's take a look at question number 4. Mrs. Keyser went shopping for scissors and rulers for her class on Sunday. She bought 8 scissors and 12 rulers for a total of $36. Monday, she went back for more. She bought 3 more scissors and 2 more rulers for a total of $9. Find the price of the scissors and rulers. So this time, it's more straightforward. We have scissors and rulers, so let's use S and R. We start with 8S plus 12R equals $36. That was her first trip. Her second trip, she bought 3 more scissors and 2 more rulers for a total of $9. Now we use the process of elimination. First, we have to figure out what we're going to multiply one of the equations by. Since we know 2 is a factor of 12, we can multiply the second equation by -6 in order to cancel out the r's. I bring over the first equation, multiply the second all by -6, and that gives me -18s minus 12r equals -54. 8 minus 18 gives us -10s. The r's cancel out, and I get -18. 36 minus 54. Divide by -10, divide by -10, and we now know that scissors are worth $1.80. Then we take that $1.80 and plug it into one of the equations. I'm going to plug it into the first one. So we do 8 times $1.80 plus 12R equals $36. And 8 times 180 equals $14.40 plus 12R equals 36. Subtract the 1440. We get 12R equals 2160. Divide by 12. And R equals $1.80 as well. So both scissors and rulers were $1.80. We could double check it by plugging it in. If we do 3 times $1.80, we get $5.40. And 2 times $1.80, we get $3.60. And if you add those up, 0, 0, 0, 6 and 4 is 10. Sure enough, we get 3, 4, 5 is 9. $9, which means that we did it correctly. And we write a sentence because it is a word problem. So Mrs. Kiesler's, or the scissors Mrs. Kiesler bought were $1.80 each, and the rulers Mrs. Kiesler bought were $1.80 each as well. All right, so the rest of the problems are going to be more like this one. Take a look at number 5. This time, the white team teachers bought 15 pizza pies and 8 bottles of iced tea for the students at the end of the school year, and their bill came to $182.60. So from that, we can set up our first equation. 15 pizzas plus 8 bottles of iced tea came to $182.60. Then the next one, 1 pie and 1 bottle of iced tea only cost $13.20. Then we jump right into solving this. So we can multiply either the second equation by -8 or -15. I'm going to go with -8. And that gives us 15p plus 8p equals 182.60. And then -8p minus 8p equals -105.60. And now we can use the process of elimination. We eliminate the 8b's. That should have been a b, not a p. 15 minus 8 is 7p equals, cancels. Borrow, 12 minus 5 is 7. 7 minus 0 is 7, and the 1's cancel out. Divide by 7, and each pizza pie equals $11. We take that 11, plug it back in for the bottle of iced tea. So 11 plus a bottle of iced tea equals $13.20. Subtract the 11. We get 1 bottle of iced tea costs $2.20. Okay, hopefully you guys are getting the hang of this. Take a look at another question. And this is the last question. So this time, a group of students and teachers went to the zoo on a field trip. 1 ticket for a student and 1 chaperone ticket together cost $30. So we have student plus chaperone equals $30. And then in the second part, we see that we have 150 students that attended and 15 chaperones that attended. So 150S plus 15C equals a total of $2,070. Now we need to start eliminating. Since we have both 1s for S and C, it makes more sense to multiply by 15, so we have smaller numbers to work with. So we multiply the top equation by -15. -15S minus 15C equals -450. Bring over the second equation. And add vertically. 150 minus 15 is going to be 135S. The 15s cancel out. And 2070 minus 450 is 1620. Divide by 135, divide by 135, and now we know student tickets cost $12 each. Plug that back into our first equation. 12 plus C equals 30. Subtract the 12. And we found that chaperone tickets cost $18 each. So that is our lesson for today. You're going to take your exit question at the end of the Nearpod and then finish your homework. I will see you all on Monday.